Inequalities and systems of inequalities in two variables. Let's consider the inequality x plus y is less than or equal to 4. We want to graph the solution set. So what we need are all the pairs of x values and y values that satisfy this inequality. So just as an example, the point 2, 1 satisfies this inequality because if x equals 2 and if y equals 1, if you plug those in there, you get 2 plus 1 is less than or equal to 4, which says 3 is less than or equal to 4, and this is a true statement. Now, the point 2, 1 is right here. I want you to notice that the point 2, 1 is not on the line x plus y is equal to 4. Now, let's also notice that the point 5, 2 does not satisfy this inequality. If x equals 5 and if y equals 2, if you plug that in, you get 5 plus 2 is less than or equal to 4, which says 7 is less than or equal to 4, and this is false. Okay, and the point 5, 2 is up here. So what I want you to notice is that some of the points that are not on the line satisfy this inequality, and some of the points that are not on the line do not satisfy the inequality. Now, I keep talking about the line. The line, of course, is the line x plus y is equal to 4. So if you were to just consider this equation, all the points that satisfy that equation are all the points that are on the line in the first place, which you can see right here. So what's happening here when we're graphing the solution set to a linear inequality in two variables is we're going to be graphing the line, which would be the equal part. And then if you have a less than or a greater than, that's going to tell you whether you're going to include the points that are above the line or below the line. Now, in this case, since we know that the point 2, 1 works and that point is below the line, what that means is that actually every point that is below the line is going to work. And notice that the point 5, 2, which was above the line, did not work. That means no points above the line are going to work. So the solution set is going to be all the points that are on the line in addition to all of the points that are below the line. So what we end up doing here is basically graphing the line and then shading above or below it. In our next example, we want to graph the solution set for y is less than 2x minus 3. So again, what about y equals 2x minus 3? Again, this is just the equation of a line, right? And we know that that line looks like this, so it's already graphed for you. But now notice that the line is dashed or dotted. Why is that? Well, it's because there's no equal this time, okay? So the equal part of the inequality was the points that were on the actual line itself. In this case, the line is actually not part of the solution. But we still have to graph the line because the solution is going to be all the points that are either above or below the line. So how do we know which ones to graph, above or below? Well, there's two ways to do this. One way is you could just do test points. So I'm just going to pick a point that is above the line. I'll pick this point right here, which is the point 1, 4. And I'll pick a point that is below the line, which is right there, which is actually the point 4, 1. And I'm just going to test those. So I'm just going to actually take these numbers and plug them into the original inequality. So here y is 4 and x is 1. And so that's going to tell us that 4 is less than 2 times 1 minus 3, which says 4 is less than 2 minus 3, or 4 is less than negative 1. And this, of course, is false. So this point up here does not work. So what we think right now then is we're not going to be shading above the line. We suspect that we're going to be shading below the line. But just to make sure, we'll go ahead and plug in the point 4, 1, which means x equals 4, y equals 1. And if we plug that in, we get 1 is less than 8 minus 3, which is 5. And this, of course, is true. So yes, indeed, we are going to shade all of the points below the line here. And then as, part of the solution, the line itself is not included, okay? So the solution set in this case is just the points that are below the line. Now, there is a second way to figure out how to shade. So if you look at the original inequality, it says y is less than 2x minus 3. So we know y equals 2x minus 3 is the line itself. And we know that y values go up and down, right? So if y is less than, basically what you're saying is you want all the y values that are less than the line. And since y goes up and down, less than means below, right? So if I have y all by itself, y has to be solved for like this. If I have y all by itself, less than means you're going to shade below the line. And that's kind of an easier way to determine where to shade. Now, the next example is a little bit more of a special case. We want to graph the solution set for x is less than or equal to 5. So if you consider the xy coordinate system, you know that x equals 5 is right here on the x-axis. But of course, remember, any point that is on this vertical line is going to have an x-coordinate equal to 5. So let's just consider, what does x equal 5 look like? And again, that's just going to be the vertical line going through x equals 5, like this. So when we want to graph the solution set, x is less than or equal to 5, we have to think about it from the perspective of x. In which direction is x less than 5? Well, there is no above or below for this line. It's either to the left of the line or it's to the right of the line. And of course, we know that if x equals 5 right here, smaller values of x are always to the left. So if x has to be less than or equal to 5, we are going to shade to the left of this vertical line. And so the solution set is all of these points to the left of that line. Now let's consider a system of linear inequalities. And this basically just means we have more than one linear inequality. So first, let's just consider each of these separately. We have y is less than 1/2 x plus 3. So let's go ahead and graph the line y equals 1/2 x plus 3. So it's going to go through the y-axis at 3, and it's going to have a slope of up 1 over 2. So it looks like this. And this is going to be a dashed line or a dotted line because there is no equals sign here. So when I graph that line, I need to make sure that I make it a dotted or a dashed line. Okay, and I'm going to label that y equals 1/2 x plus 3. The other line is y equals 1/2 x minus 2. So that has a y-intercept of -2. And it is also having a slope of 1/2, so up 1 over 2. And that's going to be a solid line. And it's solid because it's included. Now, the solution, notice that these lines are parallel. The solution is all the points that satisfy both of these. So in the first one, we have y is less than. That means below. So we have to be below this line here. But then the second one says y is greater than or equal to. So that means we have to be above this line here. So all the points that satisfy this are going to be all the points that are in between these two parallel lines. And this green line here, this solid line, is part of the solution, whereas this line here is not part of the solution. So when you're graphing a system, you're trying to find all the points that satisfy both of these simultaneously. In our next example, we want to graph the solution set to the system, and notice that now we have 3 inequalities. So first we have the inequality x plus y is less than 4. Let me come to that one last. Let's go ahead and do x is greater than or equal to 0. So we know that x equals 0 is right here. So that's the line x equals 0. Then we'll go ahead and jump to y equals 0. That's going to be this horizontal line right here. So notice that y equals 0 is the x-axis and x equals 0 is the y-axis. And then we have the line x plus y is less than 4. And you can graph this any way you want. I'm going to solve for y. And that's going to be y is less than negative x plus 4. So it's going to have a y-intercept of 4. And the slope of this line is negative 1, which means we're going to go down 1 over 1 to get other points on this line. And then keep in mind this line is going to be dotted. All right. So now where do we shade? Well, we have to shade to the right of this blue line. Okay, so we know we have to shade somewhere over here. For the green line, right, y is greater than or equal to 0, we need to shade above that line somewhere. And then for this last line that we graphed, this one here, we have to shade below that one because it says y is less than that. So we need to be shading below this line. So now we're going to shade the region that satisfies all 3 of these. And that region is going to be this triangular region right here in the middle, right? This is the only region that satisfies being to the right of this line, being above this line, but also being below this line. And so this is our solution. Next example, again, this is a little bit of a special example. We have x is less than or equal to 4. So by now we should be able to do this one pretty easily. So here's x equals 4. And we are going to be shading to the left of that line because we want x to be less than 4. And then we have y is greater than or equal to negative 3. So negative 3 is down here, right? This is y equals negative 3. And now we need to shade what? Above that line, but to the left of the vertical line. And so that's going to be this region right in here. And notice that this region is infinite, right? It goes on forever in all directions this way. Right? These are all the points that are to the left of this line and also above this line. And finally, graph the solution set for the following system. So again, there's nothing new here. You just have to solve each one of these, or actually graph each one of these lines. I'm going to solve for y in each one of these. So for this first equation here, we have x minus 2y is less than or equal to 4. I'm going to add 2y to both sides. And I'm also going to subtract 4 from both sides, right? Because that'll cancel the 4 here, and it'll cancel this here. And we're going to get x minus 4 is less than or equal to 2y. And then let's divide by 2. And that's going to give us 1/2 x minus 2 is less than or equal to y, or y is greater than or equal to 1/2 x minus 2. Now I'm going to solve for y here. So x plus y is less than or equal to 4. This one's quite a bit easier. We can just subtract x from both sides. And that's going to give us y is less than negative x plus 4. So here's my 2 equations so far. And the last one, we have x is greater than or equal to negative 1. And that one's good to go. So now let's graph all these. X equals negative 1 is right here. Y equals negative x plus 4. We just graphed that one a minute ago. That's going to be right here. And again, all these lines here are going to be solid, right? Because they all have equal to involved. And the last line, y equals 1/2 x minus 2, is going to look like this. So there's our lines. We need to be to the right of this line. We need to be above this line, right? Because that's y is greater than or equal to 1/2 x minus 2. And then finally, we need to be below this line over here, which is this one. So again, that region that's going to satisfy all three of those is going to be just this triangular region inside here. And that concludes this video lesson.